All right, good morning, welcome back. Okay, so we left ourselves here, reducing subscripts. We're taking names to formulas. Let's go ahead and keep on keeping on. Here were our notes from before that. Okay, let's wrap ourselves up. The main thing that we'll be doing in this video is going from formulas to names. Okay. And to go from names to formulas, super similar idea. Names to formula, no. Am I doing that wrong? We've been doing names to formulas. That was part one. This is part two. Here we're going to be going formulas to names. Okay, so a lot of the ideas are super similar. It's the charge of each ion that is your key, and that if there's a single thing that you want to be focusing on, it's finding the charge of each ion. Okay, so formulas to names are going to be things like when you get a formula, and you have to write the name of the compound in that formula. Okay. We know that the charge of each ion is the key, so we've got some copper, we've got some chloride, but the charge is the key. Okay. Copper is a transition metal. We don't know its charge yet. Copper's charge, we don't know, but chloride is not a transition metal. Chloride's over here. We can do the Lewis structure thing, count across. Chloride has 7 valence electrons. Your chloride ion will have a charge of -1. It will gain 1 electron to get to that full outer shell of 8. Okay, so each chloride ion has a charge of -1. And we know from here that we have 3 chloride ions. So our equation is going to say, here's our copper stuff, here's our chloride stuff. We want a neutral compound, so we want our amount of positive stuff from our metal to equal our negative charge from our non-metal. However, we don't know the charge of our copper yet. We know that we have 1 copper ion because there's no subscript. I'm going to do this in color. There's no subscript, so there's an implied 1 right there. We have 1 copper ion. However, we don't know its charge. Okay, so 1 copper ion goes with this one right there, showing that we have 1 ion in our formula. But we don't know its charge. That's what we're trying to find. We're trying to find its charge. On our chloride side, we've got 3 chlorides in that formula. So we have 3 chlorides in our formula. And each chloride has a charge of -1. And while that kind of looks like a lot, we're looking at how many of each type of ion. So we have 1 copper with an unknown charge, and we have 3 chlorides, each with a charge of -1. Do a little math. Something plus -3 equals 0. Don't overthink it. That something is 3. We now know the charge of our copper. When we write that as a name, we're going to write copper. There's our charge of 3. 3 chloride. 1 copper with an unknown charge neutralized 3 chlorides, each with a charge of -1. From our 3 chlorides, that was a net charge of -3. We want to know how much charge on each of our copper ions. There's only one, and it's got to have that full positive charge of +3. So when we write it, we say copper +3 chloride. Let's do another example. Let's do, if I give you this, there's your formula. We can draft it. We can say it's some titanium. But we know we're going to need to fill in with the charge. Here's our oxide. Charge is key. So let's find the charge. Titanium, we have 1 titanium with an unknown charge. Here's our oxygen. We have 2 oxygens, and each oxygen starts with 6 valence electrons, gains 2 more for a charge of -2, so each oxygen ion has a charge of -2. We want that to be neutral. We want that to equal 0. We've got 2 oxides, each with a charge of -2. We've got -4 from our oxides. We know that to have a neutral compound, something -4 equals 0. Don't overthink it. 4 minus 4 equals 0. That's our charge. We've got just 1 titanium ion, has a charge of 4. So when we write it, we say titanium 4 oxide. Okay. We can do one more example. Let's do iron. Okay, you might recognize, I think we did this named a formula, so you could check that if you wanted. Or, I mean, this one looks trickier, obviously. But we can totally do it. We've got some iron. We just need to know its charge. And some oxide. Charge is key. We don't know iron's charge. We know that we have 2 iron. We have 2 iron ions, each with an unknown charge. Here's our oxide. We have 3 oxides. Oh, and I even did oxide with titanium. I should have done something else. Oh well. But luckily, you're going to see a lot of oxides because they're really popular. And all oxide ions always have a charge of -2. You want this to be neutral, equals 0. Here's your math step. Something times 2 minus 6 is 0. Again, even though that looks like algebra, it's okay, you got this. Something, 2 of something equals 6. That's the charge on your iron. Your iron must equal 3. We can even check it just to be sure. That's your iron plus 3. So now you've got 2 irons, each with a charge of +3, and 3 oxides, each with a charge of -2. 2 times 3 equals 3 times 2. It works. Okay. So for your homework, you're going to do a couple questions of each type. So some going from names to formulas, some going from formulas to names. Ask your questions. Feel free to rewatch these if you want. These can be a little bit trickier, but once you kind of see this math step, you've totally got it. All right, connect with your questions and enjoy.